Hi everyone, and thanks to USF and TV seminars for this invitation. My name is Darryl Rabuli, and I'm with the Institute of Mine Seismology. Today I'm going to be talking about seismic monitoring in mines and what this can tell us about the stress conditions underground. To start with, what is a seismic event? This is a volume of sudden inelastic deformation that generates recordable or perceptible seismic waves. We say recordable or perceptible because if we don't record it or feel it, we don't know anything about the event. It may still occur, we just don't have any information. A seismic event is generally caused by the stress overcoming friction on a fault or the strength of the rock. How do we usually record these seismic waves in mines? Well, usually with accelerometers or geophones, or some combination of both. Which sensors we use will depend on the size of events we want to monitor, specifically the range of magnitudes we want to monitor. And here we can see a normalized frequency response of typical sensors. Below the graph is a rough indication of the magnitude for different frequencies. All these sensors have a good range, a good linear response between about magnitude +2 and magnitude -2 or better. Accelerometers do appear to have a better response at these lower frequencies. But the noise level on accelerometers, especially in the low frequency range, is much worse. They do have a theoretical better upper limit, but when we want to perform moment tensor analysis, this low frequency noise is not very useful, not very helpful, and we tend to prefer geophones. Accelerometers do have their uses though. So with seismic moment tensor analysis, it's good to look at the radiation pattern generated from seismic events, especially in the far field. I'll only focus on the P-wave radiation pattern just to give you an idea. And for an earthquake, where we have some slip, the P-wave radiates out in these lobes. We get two lobes of negative polarities and two lobes of positive polarities, depending on the slip directions. These polarities can be seen on the waveforms as either an upward first motion or a downward first motion. This also depends on where the sensor is relative to the source of the event.